Hello! Welcome to our new unit. Our new unit starts out with a couple of concepts that you should already be aware of, and it's 6.1 and 6.2. It's a little bit of review along with some cool formulas for areas. Now we're going to mesh these together because you'll see why. Both of them deal with solving triangles. Solving triangles meaning solving for all the angles and solving for all the sides, okay? And this guy deals with law of sines, okay? I think some of you guys, depending on your background, are familiar with them. And law of, well, if you have law of sines, we have to have law of cosines, okay? I'm going to reintroduce them to you, so I'm not assuming that you know everything. So if this is simple for you, well, good for you. Enjoy it, okay? And of course, we're going to end it with two cool formulas for area. All right, now I'm going to introduce you to both, but we're going to start with law of sines, okay? Law of sine. How do you use the law of sines to solve oblique triangles? Now, we're all used to solving something like this, which is a right triangle, because we can use trig to solve right triangles. However, now we can solve for any oblique triangle like this, a non-right triangle. A couple of things about that, a couple of conventions that we're going to keep consistent is that angle A is across from side A, angle B is across from little b, which is the side B, and angle C is across from side C. And the capital letters and the lowercase letters should matter, okay? Now, the law of sines, some of you guys may remember, but if you don't, no problem, here's law of sines for you, okay? Sine of angle A over letter over side A, and sine of angle B over side B, sine of angle C over C, the side, okay? Obviously, you can rewrite this equation to look like this, okay? You can look at, it could look like this, right? If you're looking for the side. If you're looking for angle, I would set it up this way. If you're looking for a side, you would set it up this way. Now, another convention we're going to keep throughout the unit is going to be at the end. Now, at the end, we're going to make sure that all the angles are rounded to the nearest tenths. And at the end, all the sides should be rounded to the nearest thousandths. Okay? It's just because of the angles, you'll see what happens. Okay? All right. So keep that convention with us throughout the unit. Okay? All right. Now, let's do some examples with law of sines. But before I do, let's actually write the law of cosines as well. So we have law of sines. And let's look at law of cosines. I think so. Here's another way to solve oblique triangles, non-right triangles, right? How do you use the law of cosine to solve a triangle, right? That means all the sides and all the angles of a triangle, right? And it looks like this, okay? If you're interested in the proof, you may actually go and try to discover and explore the proof for yourself. There's some patterns I hope you notice, okay? You notice some patterns here. You have the angle, you have the side A squared, and this always looks like the Pythagorean theorem, more or less, but you have minus BC cosine of A. So these guys all agree, and then you see these guys agree with here, okay? Obviously, if you're looking for the side, you would set up like this, okay? But what if you're looking for the angle? Then you would do some magic with the algebra, and you would use this formula here that I'm going to show you. But they're all related. I mean, if you rewrite these equations, you actually get this equation, because now you're solving for cosine of A, cosine of B, and cosine C. So if you're looking for angle, you would use this formula. If you're looking for sides, you would look for this formula here. Makes sense, right? Because then in the end, you're going to get a cosine of A. Okay, but how do you decide what to use when? Okay, so let's look at this, okay? How do you decide when to use law of cosines and law of sine? And I think you're going to explore a lot of examples, and you're going to be able to draw this conclusion yourself. But to make it easy for you, I have a solution, okay? Think about it. If you have law of sine and law of cosine, there's things that you need in each of them. Okay, I want you to think about it first based on the equations. But when you're done thinking about it, I hope your conclusion was this. When you have side, 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 think about why you have to use law of cosine. Side, angle side, think about why you need to use law of cosine. And as we do more and more example and practice, I know you're going to be able to figure it out. And angle side, angle, angle side, and as, so as and Those ones we're going to be, these are the special cases, and we're going to discover them later. But all of these ones are law of sines and law of sine. And these are also law of sine. But I'm going to put quotes here because these are special. Okay? And we're not going to discuss this today at all. Now, I want you to think about why, because I could ask you that, right, as a communication question, right? Why can we use SSS as SAS for law of cosine? And why do we use law of sine for SA and AAS? Now, easy way to remember, I guess, law of cosine starts with S, law of sine starts with A. Okay? All right, second video.